Algebra 2, I wanted to see if we could do the notes even though I'm not there today for 6.1. So we're starting a new chapter, chapter 6. It's all about exponents and kind of dealing with powers. You've seen these things on your skills quiz, and you should have seen most of this in Algebra 1. So it's kind of a little bit of a review, but we're going to cover it. So first thing we're going to talk about is section 6.1, properties of exponents. Okay, when dealing with exponents, we will first look at monomials. Here are some key definitions. Okay, so a monomial is an expression with one term. Like mono means one, so it just has one term. It is a number, a variable, or the product of a number and a variable. Oops, that's really not good. Sorry, my writing is terrible with this thing. So the product of a number and a variable. The numerical factor of a monomial is the coefficient of the variable the degree of a monomial is the sum of the exponents of the variables. And a power is an expression of the form x to the n power. That's an exponent, x to the n. So some examples, like a monomial, look at first. Like just the number 3. That's monomial. It could just be a number. You could have just x squared, or 5x squared, or something like that. You can have the square root of 3, x squared, y to the 5th. Okay, you can have more than one variable, but notice that they're all multiplied. There's no adding and subtracting in between them. So what is not a monomial? Okay, a couple examples of that. X minus 5. Okay, in a monomial, it's just one term, so you can't subtract, you can't add. You can't do square roots of variables, so like the square root of x, y, that doesn't work. All the exponents must be positive. So something like x to the negative 2, that's the same thing as 1 over x squared. And that is not considered a monomial. Okay, we can do something that's just a number, like 1/2 is, yes, it is a monomial. So I'll put that over here in this category because that's just a number. But we can't have the variables being divided. We can't have x squared on the bottom. So the numbers, yes, we can do that with a fraction. The numbers are real numbers, so that works. The variables have to have positive integer exponents. Okay, in the numerator, we can't have them on the bottom. All right, to simplify, An expression containing powers, when you see this in the directions, it means to rewrite the expression without parentheses. Without parentheses. Parentheses. Or negative exponents. In simplified form, you don't have these. You have to rewrite it. Negative exponents are a way of expressing the multiplicative inverse of a number. Okay, multiplicative inverse means like the opposite. The negative flips. Okay, so here, basically, the main thing is that the negative flips the location. So it either flips it from top to bottom or from bottom to top. So if we look at a few things, for any real number, when a is not equal to 0, so we can put it on the denominator. For any integer n, then there's a couple things. So 1 over a to the negative n. So if you had something with that was raised to a negative power in the denominator down here, what happens is it flips it up to the top, and you make it a positive exponent. If it's already on the top and you have a just to the negative n, to rewrite that, it flips it to the bottom. So 1 over a to the positive n. Okay, so a couple examples of this. If I have 3x to the negative 5, there's no negative exponent on the 3, so the 3 stays put, but the x to the negative 5 gets dropped down, and the 5 becomes positive, so it's 3x to the 5th. If I had 3x all to the negative 5th, then this both would go down, and we'd have 3 to the 5th, x to the 5th down here, and they would all get dropped. Sorry. All right, properties of exponents. Okay, when we're talking about properties of exponents, this means like the bases must be the same. In order to add x, in order to do what we're going to do, we're requiring that the bases are the same. And that'll make more sense when we get to a couple examples. So for any real number a and integers m and n, then when we have a to the m times a to the n, so a is the same number, so they have the same base, then what can we do with exponents? We can add them. Okay, so example of that, if I had x squared times x to the 5th, I can add those and I get x to the 7th. When you're dividing for any real number, when a is not equal to 0, so because we're going to be dividing, we can't have a on the bottom be 0. And integers m and n, and if you have them on top of each other, so a to the m over a to the n, so quotient rule, you're dividing, what can we do? We can subtract exponents. So, example, if we have x to the 5th over x squared, I'm going to end up with, if we subtract them, 5 minus 2 gets you 3, so x to the 3rd power. And this you should have all seen in Algebra 1, so hopefully this is looking familiar. Okay, properties of powers. Suppose a and b are real numbers. And m and n are integers. Then the following properties hold. So power of a power means you have something that's a power raised to another power. So a to the m to the n power. When it's a power to a power, you multiply exponents. So a m times n. Okay, so example for that, x to the 5th, if you're going to square that, you'd multiply it. So it's x to the 10th. Okay, power of a product. That is something if you had ab to the m power. So the product, a and b are multiplied, and then we're raising it to a power. You just get to distribute that exponent to both numbers. Okay, so our example, I had 3x squared all to the 3rd power. The third goes to everything, so 3 to the 3rd, x, and then we're going to multiply. So x to the 6th, 3 to the 3rd is 27. And then power of a quotient. Quotient means divide. So if we are dividing numbers, so a over b to the m power, then it's going to go to both the top and the bottom. So a to the m over b to the m. And here we just can't have b equal 0. So where b is not equal to 0 because we can't divide by 0. Also, if we had a over b to the negative m power, then what happens is you're going to distribute it, but because you have this negative exponent, they're all going to flip. So you're going to have b to the m on top and a to the m on the bottom. Because of that negative, again, remember we flip. So you're going to go to the opposite sides. So here we can't have a equal 0 and b can't equal 0 because we can't end up dividing by 0. And then the last one is the 0 power. So when we raise something to the 0, so a to the 0, that equals 1. There's only one exception. That doesn't work when a equals 0. So when a is not equal to 0, note that if we did do it, 0 to the 0 power is undefined. You try that in your calculator, say error. We can't do that.